let me just hit this. Brilliant. All right. So just a little background on the research program. I've been lucky enough to kind of be with it since its incarnation, which is probably now 7 years ago, when it was kind of a pipe dream between myself and the supervisor at the time. And we were like, wouldn't it be cool to bring this to Princeton High School? And it started out as a cohort of myself and 8 students. And we were just kind of making it up as we went along. I had visited some other schools to learn about research programs in high schools, and Dr. Sprague and I were like, all right, let's make this stick here at PHS. And it really did. And I think it just speaks to the passion and motivation of the students at PHS and your students, because now we are over 60 students strong in, it is 3 sections with 3 teachers. So we've really kind of grown immensely, and I couldn't be happier to have seen kind of where the program's going. So again, it was just designed to give students a really authentic research experience. So we tried to kind of give them a collegiate experience at high school so they can figure out if this is maybe a path they want to pursue. And myself and Jennifer Smolin and Mark Eastburn, the 2 other teachers that advise the program, have really, we've all had collegiate research experiences, and we really just feel like it shaped us as, science educators and scientists in our own right. And we just want students to have that experience, whether it ends in high school or it continues to the collegiate level, or somewhere else, who knows. So we really have, it is 60 students with 60 different passions going in 60 different directions, which, besides making us a little crazy, has produced some awesome results. And our students have had internships, and they've presented at professional symposia, and most all students leave year 1 having publications of genes that they've sequenced and analyzed, which is pretty cool. And if you get a chance to swing by the high school, you will notice that we have a room full of test subjects. So currently there are cages and cages of spotted lanternflies living in the back of my classroom as we look at mitigation tactics, which is pretty cool. A student was in our room plating anaerobic Clostridium bacteria to look at the effects of different types of fat on the bacteria of the gut microbiome, which was pretty cool. We have lots of spiders. We have blue hornworms, which I don't know if you've ever seen, but they're pretty awesome. And the kids basically dream up a project, and then we say, make it feasible. So they've gotten extremely creative in how they can answer the questions that interest them inside PHS, which is so amazing in my opinion. So we have lots of different research going on, and you may have seen 2 recent posts coming from PHS that 2 of our students, 1 senior student and 1 junior student, are about to be published. 1 student in Frontiers to Neuroscience, and 1 student in IJHSS, which is kind of a social sciences. She's looking at social support during online learning during the pandemic. So lots of really cool things. We've had students up and down the Eastern Seaboard this summer collecting lizards for an evolution study. So students can really go whatever direction they want, and students usually come in with a pretty clear direction, but if they don't, we try to help them get there, which is always exciting and keeps my job so interesting. So year 1 is where your students are right now, and we're kind of helping them develop the skills that they need to independently move through their own projects. So we have recently read scientific literature, which the students did an excellent job on. It is no easy task to read review articles and research articles and get in the mind of a scientist, but they did an excellent job. And we just started a project where they are collaborating with some scientists at University of Delaware and Rutgers University. And these scientists are particularly interested in climate change in the polar regions. So during the winter of 2020 slash 2019, kind of bridging that, these scientists went down to Antarctica and collected some data. And we now have access to that data, and our students are working to help the scientists analyze it, which is really very cool because they could be the first ones to ask certain questions and make certain findings, which I think is really authentic for the students. And they also have the opportunity to communicate what they find with the scientists on the project. So we are currently immersed in that. And we will do some genetics work later in the year, again in collaboration with Rutgers, and we will do a Western blot project to just kind of give students exposure to many different research techniques. We'll do survey-based projects, and we'll talk about statistics, and just make sure they are equipped with the tools they need to move into year 2 and 3, which is really driven by them. So at this point, we will be advisors to your students, no longer really the teaching role, and they'll drive the bus. They'll set their goals on a bi-monthly basis. They will report out how they met their goals. They will, keep running records and journals, and we'll do check-ins, but like they're running the show. And I think this is where students can really develop awesome skills in time management and communication and just self-advocacy, which is really awesome to see in our year 2 and 3 programs, students. And then, of course, we want them to communicate their science. We want them to communicate it to other scientists and also to the community at large, because we really think that is a skill that all future scientists and all future citizens kind of need to communicate their passion to people that maybe don't share that passion. So we have a research website where they can highlight their work. We take them out to elementary school so they could talk to younger students. We've had people run community service programs. So there's lots of opportunity to talk about their science. And one thing I've learned is typically the research students love to talk about their science, because who wouldn't, right? And then, like I kind of alluded to at the beginning, we're in a huge sort of growing phase, which is exciting. This is our first year where we have 2 full sections of first-year researchers. And also this year, we're really excited to roll out an in-house internal review board to review the students' projects when they propose them. So your students will be the first to experience this. And we find that, or we're hoping that this is going to give them a really authentic look at accountability in research and how important that could be in the future. And yes, we have grandiose ideas about things, but there's ethical standards that we have to adhere to. And the perspectives of a committee can be really meaningful when building out a project that is going to be feasible and, ethical and broadly applicable, which we are super excited. We will have our first meeting as a review board to train our members next week. So this is all new and exciting growth, which we love. And then, of course, we're here for the next 3 years for your student. And we really do love the partnership that this builds. Like right now, I'm basically crying over every letter of recommendation that I write for our graduating seniors, because we've just spent 3 years developing such a strong relationship. And in pretty much all cases, I have seen just incredible amounts of growth in them as scientists and students and humans, which is really, really kind of a cool place to be. I cannot complain. So that's kind of my little spiel about research. I apologize if you got some repetition if you were there on Thursday, but I hope it answered some of your questions, but I can answer anything additional that you might be wondering about. And of course, like I said, you could reach out at any point during the year.
So one question I had was, how do you help shape the really big, broad ideas into something that they can do over the course of a year or 2?
No, yeah, that's an awesome question, because they do all come in with something pretty impressive. Many humans wanting to, cure cancer and research Alzheimer's and, you know, build complex machinery. And we start with that. So we let them go big and broad. And we, at the start of the year, when they're going to write create an annotated bibliography. So they're going to scan the research and see what's going on. And when they do that, we guide them to find not only publications from, postdocs and, researchers in commercial labs, but we say find an undergrad project related to this, because there's a decent number of undergrad journals that they can access. So we start to kind of zone them in on something feasible. And sometimes we do have those difficult conversations where we're like, are you really going to be able to do this in our lab? But very often they get to that point on their own. And we spend a lot of time setting up conversations between year 2s and 3s and the year 1, so they could really see what's already going on in the program. It just gives them a better sense. And like by the end of year 1, they're already kind of policing themselves and like, is that possible? How can I do this? So we've been really lucky that most students are able to kind of land on a passion project that is doable in PHS.
Do most students work in groups or independently?
Historically, it has been independently. But recently, in the last year or so, as the program got bigger, we have encouraged groups, and students have really found it to be very meaningful to have a posse of humans to bounce ideas off of and troubleshoot with. And we've made it more of a point to show them this is how most science is done in collaboration with others. So students are kind of finding the group process to be very, very useful. But again, it's up to them, and we do have our independent workers as well.
Right. And generally, how large are the teams for the ones that are team-based? And have you seen that impact the actual research itself, in that the research can be, for example, more ambitious, or you can just pack a lot more into the project?
Yeah, so we typically see in group work that what they're able to do is have a large kind of overarching question and have several offshoots of it. So I think our best example, or the best example that comes to mind, is we've had a research team working with Venus flytraps and the action potential of Venus flytraps. And over the years, this group project has been passed on, and we've gone through iterations of looking at how temperature affects the action potentials, to modeling circadian rhythms. And we've just been able to kind of develop this depth of knowledge that wouldn't necessarily be possible in one student's 2-year project. So we do typically find that there is greater depth when we have a team of students.
Mm-hmm. And are the projects collected into some sort of a library for students to peruse prior research?
Yeah, that's actually, we are currently working on updating our research website. So our year 2s and 3s are currently, they have the assignment of writing a blog post and creating a video about their project. So that should be up and live, I would say, by the end of this month, so that our year 1 students can look through it and see kind of what's going on. And of course, we'll send that out to our families as well, because it should be a pretty cool tool when it's done.
Got it. All right, thank you.
Yeah.
So for those students, my son among them, who joined the research program only in year 2, how is their experience different?
Great question. So we have a slightly accelerated model for them. So typically the progress of year 1 is we do some group projects during the first half of the year up until January. And then we get into writing an annotated bibliography, writing a literature review, and the year ends with a grant proposal. The hope is that for our sophomore students, and we do have, our junior students who are in year 1, we do have a handful of them. We're hoping to set up a meeting with them in the next couple of weeks to actually get them started on sort of the annotated bibliography work and the grant proposal work earlier, so that during the second half of the year, they can basically start carrying out their project. So they'll almost have an abbreviated first year, but we try to get in all the key skills regardless.
So have you had students who've joined in year 2 in all prior years?
Yes, we have. I think this year is our biggest cohort of joining juniors, but we have had many, and I mean, they're usually just, it's like their passion kind of drives them, and we haven't really experienced a problem where a junior student isn't able to kind of fulfill the requirements and complete a project. We do gear them, in building their project to kind of go along with the idea that they have a slightly shorter time frame. So when developing and crafting their research question, we constantly are reminding them to keep that in mind. We also urge them that if they were to join one of these groups and kind of develop a subset of a question, there's kind of less groundwork to be done. So we will definitely bring that to their attention and make it available to them if it's what they choose to do.
And they wouldn't be required, or you wouldn't recommend that they spend the summer between junior and senior year doing research?
They definitely would not be required. We do have a decent number of students that like to do research in the summer just because some of their other responsibilities lighten up. But it is definitely not a requirement, and it's definitely not necessary. It is definitely, when they build out their grant proposal and schedule their timeline, it's just something they have to accommodate for. If they have other summer requirements, they know not to plan stuff out within that window, but they can definitely make it work without the summer.
Okay. And are you or have you guys work with industry in the local area, just partnerships vis-a-vis either access to expertise or use of facilities, or donations of equipment and so on and so forth?
Yeah, we're definitely always trying to build those relationships because they are so meaningful. We've been extremely lucky with guest speakers coming in to speak with the students, and then usually once they come in and talk to the students, they tend to be quite impressed, rightfully so, because our students are very passionate and very well spoken even from the beginning. So we have pretty good luck with students getting mentors who will read over their work and give them feedback on procedure. We have less luck getting students to be able to work in labs just because of insurance reasons, that many of them are younger. But in terms of having people to converse with about their science, I would say like 90% of our students have someone in either industry or at the collegiate level to bounce ideas off of.
And you help facilitate those relationships?
Yes. So between the three of us, we've worked in and had collaborations with Rutgers, TCNJ, Rider, Princeton University, that have afforded us the opportunity to kind of weasel our way in and be like, hey, we have this awesome student, when you talk to them, and we could usually help make it happen.
Got it. Okay. It looks like, am I the only one right now? I think so.
I think so.
Okay. Just going back to the team point, what do you recommend for students that might be thinking about forming a team or joining one, as far as kind of ideal size?
I would say 3 to 4 is typically our sweet spot. Probably leaning towards 3 has where we've seen kind of the most magic happen.
And when do students have to commit to a project and or a team?
So our people in Armand's situation, we'll probably meet with them toward like in a week or 2. So I would say probably by the time we're getting around holiday time, December-ish, I would hope that our junior students are either committed to a project idea or committed to a team so that they can move forward.
Got it. Got it. And is there a fundraising component before they can kick it off? Did I?
No, not necessarily. We have decent amount of funding from the district at this point, which is awesome. So as long as they could justify their expenditure on their like grant proposal, we're usually pretty good at making the supplies happen.
Okay, great, great. And the IRB, who sits on the IRB?
Yeah, so it is the principal of the high school, Mr. Schmiel. We have our department supervisors to kind of focus in on the specific content areas. We have Dr. Barnes Johnson from the high school who teaches our racial literacy course, and Jen Bigioni, who's our librarian. And then we also have 2 Board of Education members.
Okay, got it, got it. And can students access secondary source, literature or work through university system libraries?
Yes, so luckily, I'm working up at Ramapo College, so I have access to all of their journals and databases, and I'm also part of ResearchGate, and it's just like a forum for researchers to share their full text papers. And usually once I reach out to researchers and say, hey, we have a high school student looking for your paper, they're very generous at sending the full text our way, so that our students have pretty good access to the literature.
Okay, great. Well, it sounds like it could be a really productive and unique, part of their experience in high school.
We're super excited. Yeah, it's usually my most exciting and productive and unique experience each year. So I'm always excited to work with them.
And I imagine you probably also see interest in certain topics wax and wane too over time. Like right now, maybe there's more focus on healthcare or viruses.
Absolutely. Lots of immunology interest. We also have had a lot of students interested in kind of like the social science route, thinking about how students have been affected by the pandemic, which has been kind of a new turn, but also very, very important.
Interesting. Okay. So it's not just purely STEM in the sense that what we normally think of as traditional research. It could be anything.
Right. Yep. We've had kids go kind of political science in nature. We basically just kind of require that they can collect some form of quantitative data, but they could really go in any direction from there.
Interesting. So of the, what is the size? Like last year, what was the size of 40 kids, 60 kids in the program?
Yes, we were probably at 48 kids last year.
And how many of those had projects that were specifically STEM oriented?
I would say probably around 80%.
Okay, yeah, that was my impression. I don't know, maybe that's why I just made that assumption.
Yeah, most kids come in with the STEM lens, but some come in with the STEM lens and then realize that they can go in another direction and they'll reroute.
Right. Okay, great.
Thank you so much for joining me.
No, thank you for your time and kind of keeping us up to date. I wish more people had come. You've given a lot of good information.
Oh, well, I appreciate that. I will send out the video though for those that couldn't make it.
Okay, sounds good.
All right, thank you so much.
Thank you. Thanks for your time.
Good night. Bye-bye.
Bye-bye.